Honorable to the Judge of International Youth Conference. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
We are from Trensains Muhammadiyah Sragen Senior High School. We present our research under the title is
Indonesia, an agricultural country with abundant natural resources. The agricultural sector is the backbone of food security for 270 million people. However, behind the gurgling water of rice fields, a serious threat lurks. Climate change, rising temperatures, erratic rain patterns, and the ENSO phenomenon are eroding rice productivity. By 2024, national rice production will drop by 45%, equivalent to 32 million tons of grain. How do we respond? ENSO is a naturally cyclical climate phenomenon involving temperature, wind, and clouds that periodically fluctuates between three phases: neutral, La Nina, and El Niño. El Niño and La Nina require changes in both oceanic and atmospheric conditions to occur. The Humboldt Current moves northward from the Southern Ocean, generally carrying water with relatively low temperatures, over the western coast of the South American continent, into the tropics around Peru where upwelling occurs. Along the equator, trade winds cause ocean currents in the eastern Pacific Ocean to move low-temperature water in the ocean to the surface. This phenomenon causes the temperature of the water at the ocean surface to decrease. With the influence of the trade winds, the ocean currents then move westward along the equator and are slowly heated by the sun's rays. As a result, the sea surface temperature in the western part of the Pacific Ocean becomes approximately 8 to 10 degrees Celsius hotter than the water in the eastern part of the Pacific Ocean. This hotter ocean region causes convection, which produces clouds that give rise to rain. During El Niño periods, there is little to no cold ocean water as the water in the central and eastern Pacific Ocean heats up along with the water in the west. In Indonesia, the application of irrigation in agriculture has become very important for farmers in order to meet the water needs of the plants. One type of irrigation that is often applied to rice farms is irrigation. Surface irrigation is an irrigation system that distributes water flow to agricultural land by means of gravity and allows water to flow following the surface topography. Of the farmland. However, surface irrigation has its drawbacks. Namely, its efficiency is low because water use cannot be controlled, so that it allows for a decrease in productivity of farmers in cultivating their land. Meanwhile, a good irrigation system is certainly one of the determining factors of success in agriculture and crop cultivation. When farmers want to irrigate their fields, they will use a water pump to irrigate their rice fields. However, in its application, the control used by farmers to irrigate their rice fields with a water pump on a surface irrigation system, most of them are still done by guessing techniques. That is, farmers only rely on calculations from experience and existing habits. One example of a concrete case occurred in Daw Village, Sambangmakan, Sragen District, Central Java. In operating the water pump, the the farmers would come to the rice field and turn on the water pump switch manually to irrigate their rice field. To irrigate their rice fields. Basically, the farmer can know the calculation of water needed by their estimating the time needed and concluding that if the paddy field is irrigated with water from a water pump, then the water needs of the paddy field will be reduced. Then the water needs of the rice fields will be fulfilled within a certain time. Usually, the farmer will leave the water pump while doing other activities and will return to turn off the pump when the need for water on the land is deemed sufficient. The guessing technique makes the farmer's calculations miss so that sometimes their rice fields are not sufficiently irrigated. And sometimes farmers find their rice fields have been irrigated. Farmers find that their paddy fields have been overwatered. This results in a waste of water and electricity used by the pump. If their paddy fields are not irrigated sufficiently, the farmer will wait until it is finished or return home, or left to return home. After we see various previous problems such as unpredictable weather due to ENSO, farmers' low irrigation techniques and efficiency, and their uncertainty in estimating the water needs for each field. Therefore, a solution is needed to answer all these problems. SAVA, Smart Farmer Virtual Assistant, comes as an innovative solution to help farmers control and monitor the water needs of their rice fields automatically and in real time. SAVA uses a combination of sensors, evapotranspiration calculation algorithm, and green energy to optimize the irrigation system. SAVA works with ESP32 microcontroller-based technology integrated with a variety of advanced sensors, including soil moisture sensors to detect land conditions, flow meter sensors to measure the discharge of water used, temperature sensors to determine the temperature of the surrounding area, and ultrasonic sensors to determine the water level in the fields. SAVA uses an evapotranspiration algorithm that utilizes data on minimum temperature, maximum temperature, average temperature, crop coefficient, as well as solar radiation intensity to calculate the water requirement of paddy fields. This data is automatically processed by the programmed ESP32 and converted into the volume of water required for irrigation. SAVA offers various excellent features, including automatic pump control based on plant water requirements, notification when soil moisture drops below 20%, access via smartphone app or directly from the SAVA device with digital screen and keypad, even when the internet network is disrupted, alternative power source in the form of solar panels, enabling continuous use even during power outages.
Climate change that has occurred in recent times has had many impacts on the geographical conditions of agricultural land. SAVA Development for Now is focused on agricultural land, with Development for Now is focused on agricultural land with flat geographical conditions, such as the land in Dog Village, Sambungmakan Sragen. With the presence of SAVA is expected to be the first step in facing climate change while supporting the SDG 13 program. Through SAVA, Farmers are expected to maximize the use of technology in maximizing the effectiveness of water and make it easier for farmers to monitor rice fields. Farmers can monitor their land only through the application. Thus allows farmers to monitor paddy fields remotely. With the application of SAVA is also expected to be able to help agriculture in Indonesia in maximizing the use of water to achieve food stability in Indonesia.